Alright, in this video I'm going to be proving the law of sines, and we're going to start with the case where the triangle we're working with is acute. And we're going to just start by drawing I guess it's called an altitude. Basically a line that's going to go from one of the vertices to the opposite side perpendicularly. And we're going to call that H. Okay, and then we're going to look at these two triangles, like the right triangle above H and the right triangle below H. And we can say that, for the upper one, the sine of B is opposite over hypotenuse. Okay, the opposite to B would be H, and the hypotenuse is C. And then on the lower triangle, we can say that the sine of angle C is equal to opposite H over hypotenuse B. And then we could, multiply both of these equations by C and B respectively. And we could see, hey, both of these things equal H. And then if we set them equal to each other and divide both sides by B and by C, we see that sine of B over B is going to equal sine of C over C. And this is only half of the law of sines, right? We know that that's also going to be equal to sine of A over A. And while I could say that, my choice of which vertex to draw the altitude from was, not specific to it being A, and I could just extend that to the other one, I'll just show you myself doing that instead, and just to really convince you that all three of these things are going to be equal. And this time I'll just draw a different altitude. Maybe I'll call this one K. Okay, set up those same sine ratios. Solve for K in each of the equations to show that these things are equal. And do the same trick to show that sine A over A is going to equal sine B over B. And now, since sine B over B is equal to both sine C over C and sine A over A, we're seeing that law of sines that we're expecting. Right, now in the second case where the triangle's obtuse, we're going to do the same thing. We're going to draw two altitudes, but this time we're going to also have to use an earlier fact from trigonometry. So since you've already seen this once in the first case, and you might, kind of see where this is going, I'll do the first, kind of computation with H, real quick, because it works just like the other one. Find sine A and sine B in terms of, H and the other side length. Solve for H. Set the things equal, do the algebra, just like we did before, show that sine A over A equals sine B over B. Okay, now for angle C, this is going to be a little trickier, and we're going to have to, like I said, use something that we've, maybe already learned in trigonometry. So what I'm first going to do is I'm going to talk about the largest triangle. So I guess I need to give this last point a name. I'll call it point P. So if I look at the triangle ABP, it's a right triangle right there. And I can say that the sine of A is going to equal K divided by C. Now what I need is the fact that supplementary angles, they have the same sign. So what I'm going to need to do here is kind of draw in a little side length here. I'll put that in gray. And then give this angle a name. Maybe I'll call that theta. And the way we'll use that fact is that since C and theta are pretty clearly supplementary angles, they add up to a straight line. We can say that the sine of C is going to equal the sine of theta. Okay? And then we're going to say, all right, well, looking at that new triangle that we built on the right, sine of theta, which I now know is equal to sine of C, that's going to equal K divided by A. Okay, then I'll solve for K. See that things are equal, divide both sides by C and A. Get what I'm looking for, apply the transitive property of equality, and see that, we've got the law of sines proven there. Alright, so that's going to be all for this video. Thanks for watching.